So I have a couple word problems coming up. My 8-year-old niece, Etta Jane, comes up in a lot of my word problems. She lives in California, so I miss her, so she comes up in my mind as I'm writing these things. This is a duplicate of a problem that we did earlier in the chapter. I just cut and pasted, put it into the review here, and changed the numbers. If you went back to section, it must be 2.4. It could be 2.3. I don't have the sections memorized. You'd see this problem. Different numbered, different, it might not be 15, it might be problem 11, and maybe some different numbers in here. Anyways, Etta Jane receives a weekly allowance of $8. She gets additional $1 each day she cleans her bedroom. Write an equation of a line that can be used to find the amount of money, M, that Etta receives in a week that she cleans her bedroom, B times. And it's super easy to get this. The amount of money she gets is $1 for every time she cleans her bedroom, plus the $8 that she gets regardless. This is no algebra, this is just logic. It's $8 plus $1 every time she cleans her bedroom, and that's what this is. Her allowance, which I could have put A, but I said the amount of money she gets is $1 times the number of times she cleans her bedroom, plus the $8 she gets if she doesn't do anything. And then for part B, what would her allowance be if she cleans her room 2 times? The amount of money she's going to get is $1 times the 2 times she cleans her bedroom plus the $8 she gets in general. So the amount of money she's going to get is the $2 for cleaning her bedroom plus the $8 in allowance. Her allowance for that week would be $10. When I write my answer to part A, I don't have to have the coefficient of 1 preceding the B for the $1 that she gets each time she cleans her bedroom, but I can. Both of those are correct answers. 16 and 17 want me to solve by the substitution method. And to solve by the substitution method, you need to pick an equation and isolate a variable. So in problem 16, I'm going to pick the first equation and solve for x. So I need to pick an equation. Doesn't matter if I pick the second or the top or the first equation, and isolate a variable. Solve the equation for that variable, and generally I look to see if there's a variable that has a coefficient of 1. If there is, that's the equation I pick, and that's the variable I'll try to solve for. And in problem 16, the top equation, the variable of x has a coefficient of 1, so I picked the top equation, and I'm going to isolate the x because it's not going to leave me with any fractions. So that's kind of the first step in the substitution method. Pick an equation, isolate a variable. Once I have this done, I'm going to substitute into the unused equation. So I use the top equation. I'm going to substitute into the unused equation and then solve that. So into the equation 6x minus 5y equals to 31, I'm going to change the x to negative 3y plus 9. And when I did that, changing this x to minus 3y plus 9, I did it with the parentheses. Now I'm going to clear the parentheses. I'm going to go 6 times minus 3y and get minus 18y. 6 times positive 9 and get positive 54. I still have the minus 5y equals to 31. On the left-hand side now, I'm going to combine like terms. The minus 18y and minus 5y are on the same side of the equation. They have the same signs in front of the y, so I'm going to add the 18 and the 5 and keep the sign negative. You can use your calculator for any sort of arithmetic like this on the homework or on the test if you care to. Now that I have the y's combined, I need to get the constant on the opposite side of the equation by subtracting 54 from both sides. On the left-hand side, when I subtract 54, it cancels. And on the right-hand side, when I do 31 minus 54, I think I get negative 23. Yeah. And to finish this up, I'm going to divide both sides by negative 23, at least to finish up solving for y. This gives me y equal to 1. That's not my whole answer because there's both an x and a y. So now I need to solve for, first I solved for y. Second, I need to solve for x. And I'm going to use this equation right there. That's the nicest equation to use. I can use any equation that exists on this sheet right now, but this is the one that makes the most sense to use because if I'm solving for x, well, this one already has x solved for. The algebra is going to be minimal. The algebra that I get here gives me x equal to 6, and when I wrote my answer, I wrote it as a point. When I did the sections, I was checking answers left and right. It takes so long to do. I'm trying to keep these review videos into a reasonable length, so I'm kind of skipping over a lot of checking. 17 asks me to solve by the substitution method, and it's already set up to substitute. The reason I set it up to substitute is because the end is the tricky part. So in problem 17, I'm going to substitute the top equation into the bottom equation. I'm going to change the x into the bottom equation just like I did in problem 16. I'm going to replace the x in the bottom equation and then start doing my algebra. In problem 17, the variables are going to drop out. So if the letters or the variables drop out, there's two things that can happen. If the variables drop out and you're left with a true statement, then the system is dependent, and you write your answer in this set builder notation form. If the variables drop out and I'm left with a false statement, then I either say there's no solution, or equivalently, I can use the big math word and say that system of equations is inconsistent. So 17, the variables are going to drop out. Let me show you what form of the dropping out happens, and then I write my answer. So I'm going to clear the parentheses that I put in. I'm going to go 4 times minus 3y and get minus 12y. 4 times positive 12 and get positive 48. I still have the plus 12y. I still have the equals 48. On the left-hand side, the 12y's are opposites. They cancel. That leaves me with 48 on the left side, 48 on the right side. The variables dropped out. I'm left with a true statement. I need to write my answer in one of these two forms. Either I use this template and I write the top equation next to that vertical line, or I use that template and I write the bottom equation next to the vertical line. This says any point that's a point on this line will solve the system. It'll work in both equations for what it's worth. We don't need to get that deep into the theory here. We just need to be able to crunch through the numbers. So variables drop out, true statement, you write this funky looking answer. False statement, that's nice, you just say there's no solutions. 18 and 19 want me to solve using the elimination method. The elimination method, you have to have the x's and the y's lined up, and then after you get the variables lined up, you need to make one of the variables have coefficients that are opposites. What I'm going to do in problem 18 is I'm going to leave the bottom equation unchanged. And I'm going to multiply the top equation by 2. And when I do that, the 3y that's in the top equation, when I multiply that 3y by 2, it's going to turn into a 6y. I'm leaving the bottom equation alone, so the number in front of the y in the bottom equation is going to be negative 6y. What I'm doing is I'm creating opposites. In front of the y's, I'm going to have opposites, and I'll be able to combine the equations and cancel out the y's. Let me show you what I mean. So top equation, I'm multiplying by 2. The reason I'm doing that is to create opposites. And in my mind, I could see that multiplying that 3 by 2 would create an opposite that I need to have. So top equation multiplying by 2, you get 4x plus 6y equals to 26, just going 2 times 2x, 2 times 3y, and 2 times 13. I'm leaving the bottom equation alone. Now I'm going to add 4x plus 3x and get 7x. I set the y's to cancel. Those are opposites. 6y minus 6y is 0. And on the right-hand side, 26 plus 9 is 35. I'm almost done with the hard part. I'm going to divide by 7. I get an answer for x. But because there's both an x and a y, it's not enough to stop here. I need to now solve for y. And to solve for y, it doesn't matter which equation, but I need to pick any equation that I see on the screen right now and plug in x equal to 5. I don't like working with negatives, so I'm going to work with this top equation. There isn't an equation that's solved for y, so there isn't a great equation to choose, but the top equation at least didn't have any negatives to worry about. So in the top equation, I plugged in 5 for x, and now I'm going to do the algebra. If you start getting fraction answers when you're doing the equivalent problem on the test, you're probably making a mistake, because I generally don't try to put fraction answers to these kinds of problems on the test. So now I have the other part of my answer, and I write my answer as a point, the x first and the y second. 19 also wants me to solve by the elimination method. I need to figure out a variable that I want to drop out and get the coefficients to be opposites. What I'm going to do again is I'm going to leave the bottom unchanged. I'm not going to do anything to the bottom equation. And I'm going to multiply the top equation by negative 2. What I'm going to do, when I multiply the top equation by negative 2, when I multiply that 4x by negative 2, it's going to give me a negative 8x. And because I'm not changing the bottom equation, the top equation, when I multiply by negative 2, is going to have a negative 8x. The bottom equation, because I'm not changing it, it's going to have that positive 8x. Then I'll be able to drop out the x's. Turns out that I'll also wind up dropping out the y's. And that's not so great, but I'll deal with it. So top equation by negative 2. I go negative 2 times positive 4x, negative 8x, negative 2 times positive 2y, negative 4y, negative 2 times positive 16, negative 32. So I'm multiplying the top by negative 2. I'm leaving the bottom equation unchanged. Unfortunately, on the left side, the x's cancel, the y's cancel, the whole left side zeroes out. The right side, those numbers are opposites, so I subtract them. 36 minus 32 is positive 4. If the variables drop out and you're left with a false statement, that's the best situation. You either can say there's no solution, or this is an inconsistent system of equations, or you could say both. But either is fine. No solution or inconsistent when this happens. 2 more problems, both word problems. Another one with Miss Etta Jane. She doesn't like the Jane part, so we just call her Etta. For what that doesn't hardly make a difference. This is easy. This I could do in my head without any algebra, because the numbers are pretty friendly. So Etta has quarters and dimes. I'm going to let Q be the number of quarters Etta has. And D be the number of dimes she has. I'm not that good at making lowercase q's, so my q's are usually uppercase, doesn't matter. And you can make x the number of quarters and y the number of dimes. I just like the variables being representative of what I'm finding, just because it makes it easier when I do the algebra. So she has quarters and dimes. She has a total of 15 coins. So the number of quarters that she has plus the number of dimes that she has to equal to the 15 coins that she has. Then it says the value of the coins, the value of the quarters, which is 25 cents times the number of quarters, plus the value of the dimes, 10 cents times the number of dimes is the value of the dimes, equals $3. I can solve this by substitution. I can solve it by elimination. When I wrote the solutions this afternoon, I solved it by substitution. Let me solve it by elimination now, just so you can see the alternate way. I'm going to multiply the top equation by negative 0.1. What that's going to do is make the dimes have opposites, and they'll cancel. So I'm going to leave the bottom equation alone, multiply the top equation by negative 0.1. I'll do negative 0.10 times q and get negative 0.10q, and then negative 0.10 times d and get negative 0.10d, and negative 0.10 times 15, I don't know if this stray mark is bothering you, but that's just the stray number 15. Positive times a negative is a negative, and when you multiply by 0.1, you move the decimal over. I'm going to leave the bottom equation at 0.25q plus 0.10d equals to 3. And now I'm going to combine. 25 cents minus 10 cents here is going to give me 15 cents times the number of quarters. The d's cancel, and here this is like $3 minus $1.50. That's $1.50. The 3 stands for $3. The minus 1.5, I can think of it as minus $1.50 if I don't want to resort to my calculator. If I wanted to resort to my calculator, I'm going to need the SD button. On this left side, if I did minus 0.1 plus 0.25, my calculator gives me a fraction. I hit the SD, whoops, I forgot the point. If I did minus 0.10 plus 0.25, I need to hit the SD button to get that decimal of 0.15. Similarly, on the right side, if I did minus 1.5 plus 3, gives me a fraction, I hit the SD button to make it into the decimal. And now I'm dividing both sides by 0.15. On the left-hand side, when I divide, I get a Q. And on the right-hand side, I have 1.5 over 0.15, and I get 10. And because Q is 10, she has 10 quarters. She has 15 total coins. I know that the number of quarters plus the number of dimes is 15 total coins. So 10 quarters plus how many dimes equals 15 coins. The algebra for this, I would probably do in my head. But she has 5 dimes. 10 quarters is $2.50. 5 dimes is 50 cents. The $2.50 from the quarters plus the 50 cents for the dimes gives me the $3. One last problem, it's these ugly mixture problems that we need a chart to set up. And very specifically, I set up my chart. I took it from the homework. I have a concentration row, an amount row, a multiply row. And in the far right hand, it's your goal, the concentration percentage. And in the middle 2 columns, it's what you're mixing together. So as I read through this, Kristen wants to make 60 gallons of a 40% alcohol solution. That 40% is going to go in here. That's the goal concentration. And what she's doing, she's mixing a 20% solution and a 50% solution. And in either column, you need the amount of the 50% solution and the amount of the 20% solution. And eventually, I'm going to make those all into decimals. I'm going to say the 50% is 0.50 for concentration, the 20% is 0.20 for concentration, and the 40% is the 0.40 for when I get into my work. I'm going to let X be the number of gallons of the 50%. solution, and y be the number of gallons of the 20% solution. And so under the amount of 50% solution, I'm going to write x. Under the amount of 20% solution, I'm going to need y. And between the two, I'm making 60 gallons total, so the amount of 50% solution plus the amount of 20% solution needs to give me the 60 gallons total that I'm trying to get. I'm going to multiply down. I'm going to get 0.50x, multiply down and get 0.20y, and multiply down and get 24. Essentially have my system of equations if I sneak the plus signs between the first two columns and the equal sign between the last two columns. The system of equations that I need to solve is going to be x plus y equals 60, and 0.50x, I don't need the 0, so how about 0.5x plus 0.2y instead of the 0.0, I don't need the zeros. So x plus y equal to 60 from the amount row, 0.5x plus 0.2y equal to 25 from the multiply row. I suppress the zeros. I'm going to solve this by elimination. I'm going to multiply the top equation by negative 0.2, and that's going to help me eliminate the y's. I'm not going to change the bottom equation. I'm going to go minus 0.2 times x and get minus 0.2x. I'm going to do minus 0.2 times y and get minus 0.2y, and then minus 0.2 times 60, I'll get minus 12. So I'm going to rewrite the top equation as minus 0.2x minus 0.2y equals minus 12. And I'm going to leave the bottom equation 0.5x plus 0.2y equals to 24. The y's cancel. For the x's, I have minus 0.2 plus 0.5. I have minus 0.2 plus 0.5. SD it, and I get 0.3. So this gives me 0.3x on the left side. And on the right side, I don't need my calculator. That turns out to be 12. Now I'm going to divide by 0.3, divide by 0.3. On the left side, I get an x when I do that division. And on the right side, I have 12 divided by 0.3. I get 40. 40 is the number of gallons of the 50% solution. So part of my answer was 40 gallons of 50% solution. Now I need to solve for y. I'm going to use the equation x plus y equal to 60. I'm going to change the x to 40 and get 40 plus y equal to 60, and then minus 40 minus 40. And that's going to give me y equal to 20. And that's 20 gallons of the 20% solution. So when I typed up my answer ahead of time, I said you get 40 gallons of the 50% solution, 20 gallons of the 20% solution. This is everything that could possibly be on the test. I never put a problem on the test that isn't just like something on a practice test. When I write the test, I'll do the key, and if it takes me too long, I'll start reducing problems. There might not be quite as many problems on the test as there are in this practice test. But perfect everything on the practice test and you're safe for the test.